Picture the most tightly controlled tech company on Earth. You probably pictured Apple. Now forget that, because Huawei may be assembling something more extreme than anything Apple has ever built. A company that designs its own processors, makes its own memory, builds its own storage, writes its own software, and possibly even owns the factories producing the chips inside its own phones. Apple designs some of the best processors in the world. But Apple still buys its memory and flash storage from outside companies. Huawei appears to want none of that dependence left standing. Stick around, because this story is about a lot more than one rumored factory. It's about what happens when a company gets cut off from the global supply chain and decides the only real fix is owning the entire chain itself. To understand why this matters, rewind to 2019. That year, the United States placed Huawei on its entity list, a designation that sharply restricted the company's access to American technology, including chip design software and components made with U.S. tools. Later rounds of export controls went further, restricting foreign-made chips manufactured anywhere in the world using certain American equipment or software, closing loopholes Huawei had initially used to keep sourcing advanced processors from foundries like TSMC. The impact was brutal and immediate. Huawei's global smartphone shipments collapsed, falling from the world's top spot to barely registering in international markets within a couple of years. Google's Android services vanished from its new international phones. Access to cutting-edge chips essentially disappeared overnight. For a few years, plenty of industry watchers assumed Huawei's momentum was permanently broken. Then Huawei came back, with premium smartphones running Kirin processors built domestically, largely through Chinese foundry SMIC. Those chips didn't immediately match Apple's or Qualcomm's most advanced silicon, but their existence alone was proof that China's chip manufacturing ecosystem had progressed further than most outside analysts expected. That comeback reset the industry's assumptions about what sanctions could and couldn't stop. Now, attention is shifting to the next battleground: memory. And this is where the story gets genuinely bigger than smartphones. Let's be precise about what is confirmed versus what is still rumor, because this story has a lot of both. Multiple industry outlets, including reporting relayed through Huawei Central, SDX Central, Digitimes, and the trade publication China Tech News, have described a planned 12-inch wafer DRAM facility in Shenzhen tied to a company called Shueisha, also referred to in different reports as Shenzhen Yuexu or Shenzhen Shengweixu technology. The reported target: a monthly capacity of roughly 140,000 wafers, initially built around a 28-nanometer manufacturing process. Unverified, the specific capacity and process figures trace back to a single social media leak and a company profile that appears to date from Shueisha's founding in 2022, not a fresh 2026 announcement. Several outlets, including Xenospectrum, have pointed out that this exact 140,000 wafer, 28-nanometer figure was already being reported when Shueisha was established, meaning that 2026 coverage may simply be older information resurfacing rather than new capacity being announced. What does appear more solidly documented? Shueisha has recruited genuinely senior semiconductor talent, including a former TSMC fabrication director as CEO and the former president of Japanese memory maker Elpida, which Micron acquired years ago, as a strategic advisor. Shueisha's production line reportedly exists and is running at least some semiconductor processes, and its connection to Huawei's broader supply network is significant enough that it has drawn attention in U.S. export control discussions. The company's name, as reported across multiple outlets, is Shueisha, alternately transliterated as Shenzhen Yuexu or Shenzhen Shengweixu technology. Huawei itself has publicly denied direct ownership of a hidden network of chip factories, stating it's inaccurate to associate every semiconductor company operating in Shenzhen with Huawei. That denial is worth taking seriously. Legal ownership and informal influence are not the same thing, and outside observers can't independently verify every claimed connection. At the same time, separate reporting, including accounts relayed through the ELEC, Huawei Central, and a Bloomberg-sourced report, has described Huawei as sitting behind a wider web of roughly 11 fabs spanning memory, logic, and foundry work, built through financing, personnel, and technology transfer relationships rather than formal ownership stakes. Unverified, remove or check. The scale and exact number of these facilities cannot be confirmed through public ownership records, and Huawei disputes the characterization. Any honest analysis has to hold both of those things at once. Huawei's public denial and a growing body of industry reporting that keeps drawing connective lines between Huawei and China's expanding memory and foundry capacity. Here's the part that gets lost when people focus only on processors. A chip that does brilliant calculations is useless without memory to feed it data fast enough. DRAM, dynamic random access memory, is the fast, short-term memory your phone, laptop, server, or car uses to hold information the processor needs right now. It's different from long-term flash storage, which holds your files, apps, and photos even when the power is off. DRAM has to be refreshed constantly and read from an extremely high speed, which is exactly why it's so difficult to manufacture well. When memory is scarce, expensive, or restricted, even a genuinely powerful processor becomes hard to deploy at real scale because the whole system ends up bottlenecked waiting on data. China's most established domestic DRAM producer today is CXMT, Changxin Memory Technologies, which has expanded output rapidly and become a target of political attention in Washington, as lawmakers debate tighter restrictions on Chinese-made memory chips. That pressure is a big part of why a second Huawei-linked domestic memory pathway would matter so much. It would give Chinese device makers, and Huawei specifically, an alternative source if CXMT ever faced its own restrictions. Building competitive DRAM is genuinely one of the hardest things in semiconductor manufacturing. Arguably harder than it looks from the outside. Memory chips might seem structurally repetitive compared to complex logic processors, but manufacturing them profitably demands extraordinary process precision, very high yields, advanced materials, and years of accumulated process knowledge. A fab can technically produce working memory chips and still lose money if too many wafers come out with defects. That's exactly why the global DRAM market has stayed concentrated among just 3 companies for decades: Samsung, SK Hynix, and Micron, which together still control roughly 95% of the global DRAM market today, according to industry estimates cited across recent coverage of the Sway-Sure reports. A reported 28-nanometer starting process sounds outdated next to the tiny node numbers used to market cutting-edge logic processors, but that comparison is misleading. Memory manufacturing processes and logic manufacturing processes aren't directly comparable on the same node scale. A mature 28-nanometer memory line can still be commercially valuable in a way a 28-nanometer logic chip generally isn't anymore, because DRAM cell design prioritizes density and refresh reliability over raw switching speed. Mature, well-understood equipment can still produce genuinely useful memory for industrial electronics, networking hardware, vehicles, and mid-range consumer devices. The realistic first goal for a project like this likely isn't beating Samsung's newest chip. It's building dependable capacity using tools China can obtain, maintain, and eventually replace with domestic equipment. The DRAM story connects directly to an even bigger and better documented piece of Huawei's chip strategy. Its Ascend line of AI accelerators, which China is positioning as its domestic alternative to NVIDIA. At its Huawei Connect conference in September 2025, rotating chairman Su Zhijun laid out a 3-year Ascend roadmap. The centerpiece was the Ascend 950PR, released in early 2026, which Huawei says is its first processor built with entirely self-developed high-bandwidth memory, or HBM, a specialized vertically stacked form of DRAM that uses through-silicon vias to move data dramatically faster than standard flat memory chips. Huawei's in-house HBM, branded HiBL1 0, reportedly delivers 128 gigabytes of capacity at 6 terabytes per second of bandwidth. And Huawei has claimed the resulting Atlas 350 system delivers substantially higher performance than NVIDIA's China market H20 chip. The reduced version NVIDIA sells there under US export rules. That roadmap also revealed exactly why memory matters as much as processing power. Independent semiconductor analysts have pointed out that Huawei's earlier Ascend chip shipments leaned heavily on a stockpile of roughly 9 million TSMC manufactured 7-nanometer chip dies acquired through a Cayman Islands registered intermediary called SOFCO, a transaction U.S. authorities later determined violated export controls, resulting in a $1 billion fine against TSMC. By early 2026, that stockpile was reportedly nearly exhausted, pushing future Ascend production onto domestic SMIC wafers and Chinese-made HBM instead. Teardown analysis of earlier Ascend chips has also found components sourced from Samsung and SK Hynix, obtained before restrictions tightened, underscoring just how dependent even Huawei's flagship AI chips have remained on foreign technology while domestic alternatives catch up. That's precisely the vulnerability a domestic DRAM and HBM supply chain is meant to close. Without secure, high-volume access to advanced memory, Huawei's processor gains mean very little at scale, a bottleneck several industry analysts have described as the single biggest constraint on China's AI computing ambitions today, arguably bigger than the processor restrictions themselves. Zoom out from DRAM specifically, and a much bigger pattern comes into focus. Huawei already designs its own Kirin processors through its chip design subsidiary, HiSilicon. It sells enterprise, solid-state drives, and full storage systems under its Ocean Store and Ocean Disk product lines, and has spent years developing proprietary SSD controller technology and flash management software in-house. It builds smartphones, laptops, networking equipment, cloud infrastructure, connected vehicle systems, and data center hardware. Layer a reliable domestic DRAM source on top of all of that, and you get something unusually integrated. A company that could, at least in theory, coordinate processor design, memory specifications, storage controllers, operating system behavior, and device engineering all under one roof, rather than waiting on standardized components from unrelated outside suppliers. Apple is often held up as the gold standard of vertical integration, and for good reason. Apple designs the iPhone, its operating system, its processor architecture, and many of the supporting chips and services around the device. That tight control genuinely does produce excellent performance, because software and hardware get optimized together. But Apple's model has a structural limit that's easy to overlook. Apple doesn't manufacture its own leading-edge processors. TSMC does. Apple doesn't fabricate its own DRAM either. That comes from external suppliers like Samsung, SK Hynix, and Micron. Apple's entire strategy depends on an international supply chain staying open and available, and Apple's leverage comes from purchasing power and scale, not direct ownership of manufacturing. Huawei's ambition looks different in kind, not just in degree. It isn't simply trying to design the best phone processor or the most polished operating system. It's trying to build a supply chain that keeps functioning even if foreign governments cut off access to critical technology entirely. Because that's precisely what already happened to it once. In that specific context, owning more of the stack isn't just about performance or profit margins. It becomes a form of strategic insurance against a repeat of 2019. Samsung offers the closest real-world comparison to what Huawei appears to be building toward. Samsung designs processors, fabricates its own chips, produces its own DRAM and NAND flash, manufactures displays, assembles phones, and runs enormous factories across multiple product categories. Samsung doesn't control every single component in every product it sells, but its manufacturing depth gives it options most competitors simply don't have. Huawei, still far behind Samsung in both advanced memory production and decades of manufacturing experience, appears to be working toward a Chinese version of that same broad industrial structure. Just starting from a much earlier stage and under far more political pressure, Huawei has the financial scale to sustain a strategy like this even through years of losses, which matters enormously in an industry where smaller companies often abandon difficult chip projects once they stop generating returns. According to Huawei's own 2025 annual report, released in March 2026, the company generated 9 billion yuan in revenue, roughly $127, $5 billion and invested 192, 3 billion yuan in research and development, which works out to 21, 8% of total annual revenue, a record for the company. Huawei also reported approximately 114,000 employees working in research and development as of the end of 2025, representing more than half of its total workforce. More than 1/5 of revenue into R&D, which understates the figure slightly. The confirmed number is 21, 8%, closer to nearly a quarter of total revenue, and it represents an all-time high for the company. That level of sustained investment doesn't guarantee success on its own, but it meaningfully changes the odds. Huawei can spread the cost of a difficult, capital-intensive memory project across telecommunications, consumer devices, enterprise storage, computing, automotive technology, and energy products. And it can become an early customer for its own components, guaranteeing demand for a new fab before that fab is competitive on the open market. That built-in internal demand is one of the biggest practical advantages of vertical integration, and it's something a smaller single-product memory startup could never replicate. Huawei's other business segments back this up. Its Intelligent Automotive Solutions unit, which helps traditional automakers build smart vehicles, saw revenue surge 72%, 1% to 45 billion yuan in 2025, while its Ascend and Kunpeng computing ecosystems reportedly reached over 4 million and 8 million registered developers, respectively, by the end of the year. Its Harmony OS operating system, Huawei's in-house replacement for Android, born directly out of the 2019 sanctions that cut off Google services, has continued expanding its own software ecosystem, with more than 80 Harmony OS-based application intelligent agents launched under its newest AI framework. Every one of these segments is, in its own way, another piece of the same broader pattern. Building parallel, self-sufficient alternatives to the foreign technology Huawei can no longer reliably access. If Huawei develops a future processor while also having real influence over the memory, storage controller, firmware, and device design surrounding it, its engineers can optimize the whole system together rather than waiting on standardized parts from unrelated suppliers, adjusting power consumption, data transfer speeds, packaging choices, or features tailored specifically to Huawei's own product lines. For China more broadly, a project like the Sui Fab, confirmed or not at full reported scale, supports a wider industrial ecosystem regardless of its immediate output. A DRAM facility needs wafer equipment, photoresists, specialty gases and chemicals, photomasks, testing tools, packaging services, and thousands of trained engineers. Even early production runs that trail foreign competitors on quality generate real experience for domestic suppliers up and down that chain. Experience that can spill into other companies and make future export restrictions progressively less effective over time. For competitors like Samsung, SK Hynix, and Micron, the most immediate threat probably isn't Huawei suddenly capturing global DRAM market share with class-leading chips. The bigger long-term threat is Huawei, and by extension, China's tech sector, becoming structurally harder to pressure through sanctions at all. Export restrictions work best when a target depends on something only outside suppliers can provide. Every domestic processor, memory chip, storage controller, and piece of fabrication equipment removes one more potential point of leverage that foreign governments could use. None of this is guaranteed to work, and it's worth being honest about the real obstacles standing in the way. Memory markets are notoriously cyclical, with prices that can collapse fast when too much manufacturing capacity enters the market at once. Established players like Samsung, SK Hynix, and Micron can respond to new competition by cutting prices, accelerating their own investment, and leaning on their decades-long technological lead to squeeze out newer entrants before they can reach profitable scale. Huawei and SwaySure, if the reported partnership is accurate, would need to prove not just that they can manufacture working DRAM, but that they can do it reliably, efficiently, and repeatedly across multiple product generations, which is a far higher bar than a single successful production run. There's also a real risk of tighter American restrictions, specifically targeting this effort. SwaySure has already faced scrutiny in U.S. export control discussions, and if Washington concludes that Huawei is using affiliated or loosely connected companies to obtain restricted manufacturing tools or technology, more firms could be added to trade blacklists. Expanded controls could make equipment maintenance, software updates, spare parts, and future factory expansion significantly harder to secure. Separately, competitive pressure on the AI memory side is intensifying from an unexpected direction: global demand. OpenAI has reportedly signed massive high-bandwidth memory supply agreements with SK Hynix and Samsung, worth well over $70 billion combined over the next 4 years, tied to its Stargate AI infrastructure build-out. That kind of demand is tightening global HBM and DRAM supply generally, which cuts both ways for Huawei. It makes foreign memory harder and more expensive to obtain even through gray market or stockpiled channels, but it also strengthens the underlying case inside China for accelerating domestic memory production at almost any cost, since waiting for the global market to loosen up is no longer a realistic option. But restrictions historically tend to produce two opposite effects over different time frames. In the short term, they can genuinely slow production and raise costs for the targeted company. In the long term, they tend to convince a large, resourceful country that dependence itself is the real vulnerability, which accelerates exactly the kind of domestic replacement effort we're describing here. Huawei's current semiconductor strategy is, in a very direct sense, a downstream consequence of being cut off from suppliers it once treated as normal, dependable business partners back in 2019. The more external pressure increases, the more resources China's government and its tech companies appear willing to direct toward eliminating every vulnerable dependency, one component at a time. There's a separate, better documented piece of Huawei's chip strategy worth highlighting, because it shows how the company is trying to compete, even while its access to the most advanced manufacturing equipment remains limited. Architecture and packaging innovation instead of relying purely on smaller transistors. In March 2026, Bo, president of Huawei's Semiconductor Business Department, published a technical paper introducing what Huawei calls the Tau scaling law, alongside a chip design approach it calls logic folding. Rather than shrinking transistors further on a traditional flat layout, logic folding stacks multiple layers of logic circuitry vertically, connecting them through extremely fine pitch bonding, to pack more transistors into the same physical footprint at a fixed manufacturing node. Huawei's published figures claim roughly a 55% increase in transistor density and a 41% improvement in energy efficiency compared with its prior generation Kirin chip, alongside a reported 7% increase in peak clock speed. Independent third-party verification of these figures is still limited, since they currently come primarily from Huawei's own technical paper and public statements. Unverified, remove or check specific performance percentages have not yet been independently benchmarked by outside labs. The first commercial chip expected to use this approach is a next-generation Kirin processor, reportedly planned for Huawei's Mate 90 flagship smartphone series later in 2026, according to industry reporting. That timing lines up with Huawei's broader pattern. Instead of waiting until Chinese foundries can fully replicate every stage of the global cutting-edge manufacturing process, Huawei is redesigning its products around the manufacturing capabilities it can actually access today, leaning heavily on architecture, packaging, and software optimization to close the performance gap left by restricted lithography access. That same logic extends naturally to memory. Combining processors into larger, more capable systems tends to make memory bandwidth and data transfer latency the real bottleneck, not raw computing power. A company that only designs the processor but depends entirely on an external memory roadmap has limited room to optimize. A company with real influence over both sides gains the freedom to experiment with packaging, interface design, memory capacity, and power targets built specifically around its own products, which is exactly the kind of coordinated advantage Huawei appears to be positioning itself for. So where does that leave us? Huawei is very likely still years away from genuine semiconductor self-sufficiency, and some of the more dramatic claims about a hidden 11-factory network almost certainly overstate both the scale and the level of direct control Huawei actually has today. Teardown analysis of its own AI chips still finds foreign-made dies and memory inside them, which is a real reminder that vertical integration on paper and vertical integration in practice remain two very different things. Huawei's own public denials deserve to be taken seriously, even as industry reporting keeps circling back to the same connections. But dismissing the strategy outright because its first products trail Samsung, SK Hynix, or Micron would repeat exactly the mistake a lot of analysts made before Huawei's smartphone comeback earlier this decade. Huawei doesn't need to lead the market immediately. It needs to keep producing, keep learning, keep improving, and keep removing one external dependency at a time, a strategy it has already executed successfully once in processors after being cut off in 2019. If Huawei eventually secures reliable domestic supplies of competitive processors, DRAM, SSD technology, and advanced chip packaging, the United States will be facing a fundamentally harder target than the company it originally sanctioned. Apple will likely keep building faster, more profitable, more polished devices for years to come. That part of the competition isn't going anywhere. But in an increasingly fractured global technology landscape, Huawei may end up holding something that's becoming genuinely rare and valuable: the practical ability to keep building, even after outside suppliers have been ordered to stop selling to it. So here's what we want to know from you. Is Huawei quietly assembling the next Samsung-style semiconductor empire, built out of necessity rather than choice? Or will manufacturing limitations, cyclical memory pricing, and continued geopolitical pressure keep it permanently behind Apple and the world's leading chip makers? Drop your take in the comments below and let us know which part of this story you want us to dig into next. And if you want more deep dives into China's chip industry, memory manufacturing, semiconductor sanctions, and the broader global technology race, subscribe to the channel and turn on notifications. Because this story is still developing fast, and we'll be tracking every confirmed update as it happens, separating the verified facts from the leaks and the speculation.